Good morning, good afternoon, good evening. Okay, let's move on to looking at area between curves using integration. So, don't really need any kind of axes here, but I'll just put in a horizontal axis there. And I've got some kind of curve there that may be modeled by some kind of mathematical function. I'll just call it y equals f of x. That's fine. I need another one. And I'll call this one y equals g of x. So as the title says here, we're looking at areas between curves, so that it has to be totally enclosed between the curves. So this is the area I'm looking at here. So what I also need is the extreme left value horizontally and extreme right value horizontally. I'm referring to these as x values. So there's four things here. There's the two curves, f of x and g of x, and there's the two x values, which I'm just referring to as a and b, just generalising here. So I'm using the application here to calculate areas. So you've seen the integration symbol before, the big extended S to the right of the equal sign, and on the right the dx, it just means in relation to x. So I have my limits, a to b, and top minus bottom. So I'll explain what I mean by top minus bottom. But this is just our rule here, our formula, whatever you want to call it. So there's going back to the graph here. So there's my four things that I need. So it's this area I'm looking at here, enclosed between the curves. Anything to the left or right of A and B, not interested in that. So that's what I'm interested in. So when I'm referring to top and bottom, as I come down to the central region of the area, that is my top curve or top bound. And as I come in from the bottom here, heading towards the central mass of the area, that's my bottom curve. So this is where I get my top and bottom from, top minus bottom. So, and because I was looking at f of x and g of x, I just want to point out, why is f of x the top one? Well, you can see if we trace it here, the top bound there, if I just come along here, that's why it is f of x. And the bottom bound here, it's actually g of x. So that's why it was f of x, take away g of x. Just to be, you have more specific curves or equations, functions. Okay, right, so that's our general rule here. So let's just go in for an example here. Looking at area bounded by y equals 4x take away x squared and y equals x. So I've got a parabola and a line. I'm going to give you a little graph here. Sometimes it's useful having a graph. It might not be that accurate, but it gives us a kind of general indication here. So what we're looking at here is we need to find the limits of integration. So we're interested in where the line meets the curve there and where the line meets the curve there. Sometimes they will give you these. Okay, so it'll be these x values I'm interested in. So this is the limits I'm interested. So what I do is I equate the curve. So y equals x and y equals 4x take away x squared. So it doesn't matter what order you equate these in. What we're going to do is take everything over to one side and have 0 on the other side. Okay, I've got a quadratic equation here on the left. I can factorise that, that's what I'm going to do. That's fine. If you want to use a quadratic formula, then do so. So here, I get something times something equals 0. That is only possible if x is 0 or x take away 3 is equal to 0. X equals 0 is a solution. X take away 3, a little bit of work with that. So eventually I get x equals 3. These are my two limits of integration. So I put the limit 0 to 3 on my summation sign there. If you want to call it an integral sign, it's up to you. Top minus bottom. So the top minus bottom is 4x take away x squared. That was a parabola. Take away x or take away y equals x. That was a line. So I'll get rid of the brackets here. That's fine. Let's gather like terms. Okay, so now we can just proceed with the rules. So 3x to the 1, that will become 3x to the 2 over 2. The other one, the x to the 2, will become x to the 3 over 3. That's me integrated. I packed it up in rectangular brackets here, moved my limits to the right, and I'm now going to insert my limits once I've cut and pasted. Here, the 3x squared over 2 take away x cubed over 3. So they're identical. So put in my upper and lower limits, okay, and start evaluating. So 3 times 3 squared over 2, 27 over 2, 3 cubed over 3, 27 over 3. Looks like the contents of that second bracket on the right is going to be 0. That's fine. And then just tidy it up here. So we'll get a nice answer. 9 over 2. Or if you want to write that as 4.5, or we can actually decimalise that. That's fine. So it's whatever you want. You put that answer in whatever form you want. There's nothing wrong with fractions, but sometimes you might need a decimal answer. Depends who the recipient is of all your good work. Okay, because we were talking about area here, I'll just put in units squared. Okay, same again. Get 2 bounds here, y equals 2x, y equals x squared, take away 6x. So again, a line, a parabola. Little diagram here. I need to find where the line meets the parabola, the x values. So I'm going to go and look for the limits again. So here's my limits. Just equate one to the other, get everything over to one side. And that looks similar to the last one. I can just factor out an x here. That's what I've done. I'm going to separate and solve. So x is equal to 0, or x take away 8 is equal to 0. That's fine. X equals 0 is a solution, and x equals 8 is a solution. So I've now got my limits of integration. So with the limits, top minus bottom. So here we go. Just refer to your graph if you have one to make sure that's correct. Please just watch the second bracket. It's got a negative in front of you. That's really a -1. So it's -1 times both of these when I get rid of the bracket. So both of these, their signs will change. So that's how I end up with that. And it looks as if I can gather the x terms of 2x plus 6x is 8x. Take away x squared. So now I'm ready to integrate. Okay, here it goes. So increase the power by 1 divided by the power in both of these. That's what I've done there. The 8 over 2 on the left hand side, I can simplify that. And that's what I've done. Okay, now I can copy and paste and then insert my limits. Remember, it's always a minus between these. Insert my limits. Okay, 4 times 8 squared, that's 4 times 64 is 256. 8 cubes is 512 or 3. Again, the contents of the right hand larger bracket or 0, but we just go through the motions. Use your calculator for this. It'll probably give you a fraction coming out at you here. 256 over 3, that's not exactly divisible by 3. So what's that? 240 divided by 3 is 80. 15 divided by, or 16 divided by 3. So I'm going to 85.3, something like that. 85 and a third. Yeah, 85.333. Again, it depends the form you need your answer in. So we got a choice here. Fractions are nice if there's no story, no context. And because it was an error, it is units squared. That's fine. Okay. Again, you can go for this. So you can pause the video here and have a go looking at the enclosed here of these two curves. The thing about these two, I'm going to give you a little picture here, is they don't meet at the origin. So we don't have an x value of 0 here. So that's just a rough sketch there. So you can go ahead and find the limits by equating one curve with the other, solving for x, and then integrating top minus bottom. Okay, you've paused the video, you went and solved it, or have you? Or are you just waiting for me to do it, as per usual for some of you? Let's go for it. So, get the limits, because they haven't given us let one equals the other in any order you want. Let's gather all the terms on the left or the right. Okay, so we've ended up with a quadratic equation. It's not just single x squared, so that can get factorized, or you can use a quadratic equation, up to yourself. I can factorize that, I'm going to do so. Okay. If you're not up to factorizing quadratic equation, let's solve for 3x. Take away 2, 0, or x, take away 2, 0. So it's going to have x equals 2/3 or x equals 2. Right. So that looks fine. Leave it as 2/3. Don't decimalize it. Okay. So the area is from 2/3 up to 2, top minus bottom. Just get the curves in the right order. So that looks like ax take away 2x squared is the top one, x squared plus 4 is the bottom one. Follow the track of the x squared plus 4. You can see that's definitely the lower bound. Okay. So top minus bottom. There you go. There we go. We get two functions in there. What's that second one? Remember the negative is -1, so basically these signs will change. Let's group similar terms. So we've got 8x, we don't have any other x terms, so it's 8x, the -4 and n is going to stay, but we'll get -2x squared to give it x squared, it's going to be -3x squared. It's fine. Can't gather anything, let's integrate. Okay. Just use your appropriate rules. Integrate, so 8 over 2x squared is 4x squared, 3 over 3x cubed is just x cubed, and it's negative, and -4x is just leave it. Right. Okay. They all have got different powers of x, so nothing can get grouped any further. So let's copy and paste this on two occasions with a minus between them. That's what we've done here. And let's put in our upper and lower bounds, so 2 and 2/3. So 2 goes into the left hand one, 2/3 goes into the right hand one. Okay, that's a left hand one done, right hand one done. Okay, so calculator time, the one on the left looks like nice numbers. So 4 times 2 squared, 16, take away 2 cubed is 8. And then we're taking away another 8, so that is going to be 0 in there. And other one, I've just sorted the other one with my calculator, or your calculator. 16 take away 8 is 0. Right, this second one, I know what I've done here. I've made a common denominator of 27. You don't need it. Your calculator can sort that out in one go. Okay, so I have knowledge of how to make a common denominator. So should you. If you were at school that day or college, wherever, it doesn't matter. You can go from this line here and you'll still come out with an answer. Of that there. So we get 0, take away a negative, so negative, negative, positive. 32 over 27 units squared. So what you got there, 32 over 27 squared, it's up to you. If you want to decimalize that, so what's that? A little bit less than 1.2, something 1.18, 1.19, something like that. It doesn't matter. That'll do us here. Right. Okay. Here, a lot of time they use lines and parabolas. So if the parabola is positive here, x squared, that usually will be the bottom in relation to the line. If, however, the parabola is negative, x squared, that'll be the top in relation to the line. That's fine. So that's what we've got there. That looks okay. Right. Okay. I think I'm fine with that. So, and there's be a little bit of homework for you if you wanted to do some homework. So, up to yourself. I'm not going to give you the answers. I think I'm going to leave that there. Yep, I'm going to leave it at that there. Okay, that was short and sweet for that one. So I'm just going to pause that and upload it when ready.